So I work at Mozilla. I haven't worked there long. I'm pretty new to the project. The first thing to understand about Mozilla is never call it the company. Always call it the project. Because it's probably the most dysfunctional company you could ever work for, which I think is a good sign if you want to change the world and do some interesting open source. I was invited here to talk about Persona, which is a privacy-protecting, distributed, federated identity system that Mozilla's come up with. It's pretty cool, and we're going to get into it a bit later. But one of the things I've found about working for Mozilla is we make this little thing called Firefox. There's about 600 million people use Firefox. On any given day, about 195 million people use the web browser. In many ways, Mozilla historically has known how to do one thing and one thing only, which is build and ship Firefox. The project is evolving, I would say. We're doing other things now. But Firefox is still really the core of what we do, right? A web browser is, I think, one of these core pieces of engineering that's becoming almost a rare commodity in the software business, right? Millions of lines of code, hundreds, if not thousands of programmers. I don't think I put the slide in. We have 800,000 bugs in the bug database we track. They're not all open at once. It's a large-scale software engineering effort. And so one of the things I find being a Mozilla personality is something I think Isaac actually inspired me to talk about more directly. So one of the things that we find at Mozilla is a lot of skepticism, that we could actually know what the fuck we're doing, right? The fact that they thought that, hey, you guys are never going to be able to compete against Google. They've got super smart engineers. They've got massive infinite budgets. They make amazing products. It's just going to be amazing. You guys should just give up. All right? I actually have this conversation fairly frequently, usually in less direct form. And so I thought today what I'd do is, rather than give my original talk, which was about very interesting, low-level, nerdy things about JavaScript and distributed systems, I would completely ignore all of that and rewrite all my slides this morning and take a bit of a different angle. For one thing, I think we've already been bombarded in this conference so far with kind of like scale and super nerd, low-level system stuff. But I'm going to float up a little bit and have a little bit more fun with it. So one of the neat things about Mozilla is that we will kick your ass. I don't care if you're Google. I don't care if you're Microsoft. I don't care if you're Opera. When you put hundreds of passionate people together on a project, sometimes it goes horribly wrong and people argue and it goes political and it all goes nasty. Sometimes people actually just do the right thing and we make amazing things. We just shipped a new version of the browser last week. It's got some pretty amazing developer tools in it that I think are really leaps and bounds above anything else in any other browser. And I wanted to highlight it just because it's a good example for me of, and again, focusing on the console, taking your whole web development experience and turning it into a command line. It's a great example of really the Mozilla mission, which is just make the web better, right? And that manifests itself on a lot of different ways. Primarily at Mozilla, it's meant making a better web browser. Sometimes we've been good at that, and we've made a great product. Sometimes other people have made a better web browser. That's super cool. The one thing we're not going to do, though, is lie down and wait for someone else to do our ideals. So one of the things we're doing that's completely crazy and almost certainly not going to succeed is make a phone operating system. This is a pretty fun project. It started with about 5 to 10 people, maybe 18 to 24 months ago. By about a year ago, it was at 20 people, still very much a research idea. And then we did what any, crazy organization like ours does on a regular basis. We decided to just go full bore on this thing. Right, so we've announced that we're making this operating system. We've got 2 carrier partners. We've got 3 OEMs signed up, Qualcomm's a partner, Telefonica Digital's a partner. We're going to ship into launch markets in Brazil, Latin America, and Eastern Europe. And we're going to do it all within 18 months of conception. So there's two ways you could react to that. One is you could be skeptical and cynical and say, you guys will never do it, right? It'll never happen. You'll never pull it off. You know, I was just talking to Kian about, kind of experience and age. Soon I'm going to have my 40th birthday. I've done quite a few large software projects in my career. Not the least of which being before Mozilla, I was the CTO of Joyent and hired Ryan and Isaac and gave Felix the first contract for Node to do the MySQL driver. I got Bart and Ben and everybody to work on the project. One of the things I've found is that trying to predict success or failure on a large software project is completely pointless. So I actually have no concern at all about whether or not we're actually going to succeed at landing this phone operating system in 9 months from now. Because every bit of experience that I've got in my body tells me any measure I could take right now is irrelevant anyways. This product is going to either happen or not based on, do people want the product? Do people get excited about it? Do they love it? Is it solving real problems for people? Can we build a really engaged community around the project? If those things happen, we will ship this. We will ship it to millions of people, and it will be a target that you'll have to deal with on the web. I tend to get pretty passionate about this stuff because for me, this device and really the next 10 years is all about how the next 2 billion people on this planet are going to come online. Are they going to come online the way everyone in this room has, with access to an open web and open information? Can they go to 4chan and post inappropriate, nasty comments? Or are they going to live in a curated Apple App Store, right? Which is great and beautiful and lovely and very clean and white. But my world often isn't so clean. So this is a big deal. It's a big deal for a lot of Mozillians. I think it's a big deal for the web that we're going to try to do this. And I just wanted to spend that just 2 minutes detour on Mozilla. And the fact that we're a little crazy, we're a little dysfunctional, we're like any big family, right? We throw things across the dinner table at each other. But we're not afraid to do things. I think when people hypothesize about the role of Mozilla in a decade, are we going to be around in a decade or not? It's really going to come down to, are we afraid to do things? Or are we just going to buck up and go do it? So persona for me is one of those things that's right in this category of guaranteed fail, will never go, adoption's too hard, beaches full of dead whales in the identity space. Sign me up. That's kind of my view. So what is persona? Well, persona is attempting to solve one problem really, which is you web developers are kind of real shitty at security stuff. The web's pretty crappy at figuring out how to store information securely on servers. So compromises happen. This is, you can't see the reference where I've got this from, but this literally is a tag cluster format of the most popular passwords pulled out of a sample of 2.6 million passwords out of a real life compromised site. So what is the most popular password in the world? Password. What's the second most popular password on the planet? 1, 2, 3, 4, 5, 6. Passwords suck. So persona is attempting to do something which a lot of other people are doing too. The no password guys are, the OneID guys are, in some ways OAuth flows, OpenID, lots of people in this space, and it's great. And our only real mission is to have somebody improve the state of the art here. Maybe it'll be us. I was going to do a little demo just to make it clear how this works. So what does a persona look like? It's a little button on a website. This is my little task site. I get to log in. We render this off the persona website. And then I just say sign in. That's it for a persona login. This presumes me, the end user here, have signed into the persona system in the past. I visit the site, I say login. I stuff some JSON at the backend website here, which I'm going to go through, and I can do a login. And for the developer of 123 done, our little sample app. Never, if I'm that developer, I never have to actually deal with your password. I don't have to store it. I don't have to know what it is. I don't have to worry about whether I ran the bcrypt algorithm 7 or 10 times, whether I've got 128 bits or 36 bits of entropy. I don't have to wonder about how I sort my database properly. I don't have to wonder if I've got my MySQL table permissions right or wrong. A lot of things I don't have to worry about. It's really, really handy. It should do that. So that's what it looks like to an end user. We've done a tremendous amount of user research and UX on this. I'll put up the URL at the end for where all of our reference material is, but certainly for UX people, there's a fascinating case history we've got of user research on this and what regular normal internet consumers perceive on the web when they use something like a Facebook Connect. It's really fascinating. So what is the thing? What is Persona? What is Browser ID? So the first answer to that is Persona is the Mozilla product. Browser ID is the protocol. As I mentioned, Persona is designed to be distributed. Federated might be another word for that. The end game for Persona is that Mozilla is not involved. The protocol is designed to be federated. It works on a really simple concept, which is proof of email ownership. That is your identifier in the Persona system. So how does this work in a block diagram form? In this case, here's our user, and here's Gmail, say. We're predicting a future world here where Gmail supports Persona identities. This could be Yahoo. This could be you in your own. This could be me with my vmunix.com domain if I chose to implement an identity primary on my own. Could be Microsoft, Hotmail. Whoever decides to do this. Me, the end user, I need to authenticate to my identity provider, an IDP, and identity lingo. That really just means I'm going to generate a public key myself on the client that represents me, my person. I'm going to give that public key to my identity provider and basically just make one request. Can you sign this for me, please? The identity provider signs my public key with their public key and hands it back. At that point, I've got a signed statement from a provider that I own the email address I'm claiming to have. All I do then is I give this bundle of signage, a little crypto magic bundle, a certificate, to the website that I'm visiting and say, here's who I'm asserting myself to be. It's as simple as that. Okay, how does it really work? You load a JavaScript library, this thing here. You set up some login and logout callbacks. They look kind of like this. You notice a navigator.id.watch. I'll get to that a bit later. In this case, I'm going to look for a few events, a login and a logout. I'm going to add some actions. Send me to home, send me to logout. Dead simple, right? Put on some buttons, whatever. It's important to understand that all we're really asking for in Browser ID from a user interface perspective is to ask your end user for their email address. That's all. We don't need to say, hey, render our fancy Mozilla login button and do a NASCAR slider alongside of OpenID, alongside of Facebook Connect, alongside of your Twitter login, alongside of your Gmail login. Just give us an email address. The same thing you're doing on your own web forms. And then you verify proof of ownership. Here's what a little verifier looks like, which basically does some magic crypto voodoo to confirm it. And really all you're getting back is a simple blob of JSON. A status saying, okay, we're good to go. Here's the audience. This is obviously a security measure, so you don't automatically just pop into sites as you troll through the web. An expiration. I took this from Francois' slides. And an issuer. It works in all major modern browsers, even IE8. We built it to be browser neutral first, which was actually a politically devastating thing inside of Mozilla, that we didn't implement this in the browser first. But you know, we're a little bit different. It works on all the mobile browsers, works on every version of the built-in Android browser back to 2.0 or 2.1, I think. All versions of Chrome and mobile, works in iOS WebKits. And of course, it'll work in the Firefox OS. So one of the interesting things about Firefox OS is you remember that navigator.id function? Well, of course, we can implement that directly in the browser and do all kinds of nice things without having to pop up iframes and do fancy, crazy XHR stuff to make all this stuff work. In the Firefox OS device, part of the unboxing experience will be creating an account. That account will be identity, Mozilla persona based. So your identity on that device will be based on this kind of technology. As you go to app stores, as you install apps, the user will end up asserting their identity to any sites they visit with this technology, which will be pretty cool. And of course, it'll be in Firefox itself. If you want to have a really cool sign-up experience with zero friction for 600 million users, you might want to take a look at it. So what's this got to do with Node.js, right? Back on topic as we blast through the last 10 minutes here. You remember in that little bit of JSON I showed you, there was this little key identifier issuer. Here it is here. This could say gmail.com. If this was, mark@gmail.com, that could be the issuer. We're a little bit sneaky in the way we design browser ID. We realize we have a bootstrap problem, right? How do you get a lot of people to adopt this? Isn't the barrier to entry to adoption in the browser ID we have to get Gmail and Yahoo and everyone else to run the protocol or it doesn't work? Well, no, we have a thing called secondaries, which basically means the issuer can actually be different. Really all you care about is the email and the status. But notice here the issuer changed from Mozilla to login.mozilla.com. This is where Mozilla, for this domain, runs the IDP directly. But we also have a special secondary that Mozilla has basically signed up to run for a decade. For any email provider that doesn't yet support the browser ID protocol. So that's how we bootstrap. So what is login.persona.org? It's a fallback IDP. It's how we bootstrap browser ID into the fabric of the web. Anybody with an email address this way can use this identity system and claim ownership of an email. That presented a problem for us. We need to run an identity system that essentially is the fallback identity play for the entire web and 600 million users. That's a big system. We kind of don't want it to go down. That means we have to run it in lots of different data centers, and we have to do all the things that the big boys do, put on the big boy pants and deal with outages and data centers going offline and all kinds of just really nasty, ugly stuff. We chose to do this in Node, which in many ways isn't actually intuitive. For one thing, Mozilla doesn't do a lot of services, but the services we do run, we generally write them in Python. Most people who write these kind of services will tell you, probably you should write them in Java. I'd actually probably agree 9 times out of 10. You probably should write this in Java. The libraries are significantly better. The maturity of the code is a lot better. The patterns are more understood. The support's available. You probably should do it in Java. But again, we're Mozilla. JavaScript's in our blood. Evented.io is all right. It's a pretty good way of doing stuff. We like the low memory footprint, and the interpreter's pretty quick. That's really why we chose Node, not because we had any big philosophical bents to go prove anything. We just think it's pretty good. So here's the browser ID project. I don't know if I would say it's a large application. I wouldn't say it's a small app. Substack might go into convulsions, for example, if you saw the amount of code in this. We are looking at individual contributors with 250,000 lines of code changing over the project. We are looking at 1 million lines of code in and out of the system over about 12 months. So it's not small, which presents some problems. But it's not all super complicated. I was going to show you that it's actually, the dependencies aren't too bad here. One of the lessons we learned is, which I think is great for Node overall, is don't use it like a glue language. Just keep as much in Node as you can. We really minimize our surface area where we call out to external libraries. One place we do call out is on bcrypt. That would actually be brutally slow to do in JavaScript directly. So we do use a library there. That is the only native call out we make in the entire thing, which means we're doing a lot of crypto. We have one little trick we play also where we do one little bit of matrix mass multiplication optionally with libgmp. But it's not bad. One of the things we found is we did have to go improve a few things. I'm going to quickly highlight a few of these, but this is Mozilla, so this whole project is open source. So I think it's a great place to go for anybody who wants to figure out, like, how do people build apps that are a little bit out above and beyond maybe your standard just web page app in the wild. We do some things well, some things not. It's actually just a regular old Express app, although we use almost nothing from Express. It's mostly Connect, which is like Sinatra middleware for the Ruby people. We did have to invent a few little pieces of middleware I think that are kind of cool. One is the sessions and Connect are kind of garbage, and we're kind of security paranoid, so we had to do them better. We invented we implemented a caching middleware. Really important for us to get all the TTL headers and everything right on this stuff, so it goes web scale. The rest of it is pretty normal. We use MySQL as a database. We terminate SSL in dev mode and Nginx. In production, we use hardware SSL termination, but gobbledygook, that's mine, thank you. So one of the things I think makes us a little bit different from maybe a lot of the presenters that have spoken so far is we're kind of old and curmudgeonly, and we don't actually we're scared about pushing things straight to production. For one thing, this is an identity system for the web, so the cost of an error and a mistake can be quite a bit higher than in our task app, for example, right? If I'm just pushing it, making my 1, 2, 3 done app, I don't really care if I have a security bug that much. I don't really care if I have a regression that much. In this system, I kind of care a lot. I don't want it to go down ever. I don't want there to ever be a security problem I can't fix immediately. So we do use a train-based release model. We do a full QA cycle on each train. QA can and does reject, derail trains for us. We live and die on that QA process. The QA guys drive a very large functional performance test run for us. Plus they do end user testing against all of the browsers, for example, to make sure all this magic iframe stuff works right. We don't view source code as a viable deployment vehicle. We demand static, signature-based assets we can deploy on the servers because, for one thing, we load inside of an RS spec. That's sort of like a restricted profile in the kernel that tells the kernel what application bundles it's allowed to run and not. So if somebody modifies a binary for us, we instantly know when it's taken offline. Kind of important for preventing Trojans in the system. We have to go through regular security reviews. We have to go through third-party security audits. Yes, we have unit tests. Yes, we do regression tests. Yes, we do functional tests. And of course, we do full load tests on about $500,000 worth of servers just for doing the load test each time we promote a train. The trains go every 2 weeks. As an example, the last 20 trains. And since I can't resist Mozilla memes, this happens sometimes. Review requests are coming. No line of code goes anywhere near the code base without being code reviewed. We also have what's called an ops first principles, which I was going to briefly show. Actually, let's go. And we actually publish this on our wiki because that's kind of the way we are. We kind of value careful change control. We have rules of engagement for developers promoting stuff to production. This is not too dissimilar from, say, SRE. When you make a product and it's successful at Google and it gets treatment from a site reliability engineering, you don't get that until you kind of make it past some criteria. We can have no single points of failure. Close contact with the developer community. We require design overview on the operations side before the code goes to production, or even really gets written. We have operational readiness guidelines, and privilege and responsibility are coupled. I'll put the URL on the slides that I send out around afterwards. But this is basically our contract we make with the developers on the operations side. I'm going to try to go quick to finish this up. We're almost there. So your reaction might be, this sounds fucking horrible, right? How do you guys survive? I mean, can't you just push code? Isn't that supposed to be the new way? Just go straight to production, right? Trust the developers, trust them. There is some truth to this. The good thing about a hardcore crypto system is cryptography is brutally unforgiving of bugs. If you have client and server-side certs being checked and you make a bug in your cryptography, it's going to blow right up, which is very, very nice property when developing a security system. So counterintuitively, sometimes more crypto equals more better when trying to find bugs in a in a security system. To answer the question, it sounds horrible. It's not as bad as you think. And this is where we get into our tooling. So we've been at this for about 16 or 18 months. We've developed quite a bit of node tooling. I'm going to pick a couple little projects out that you guys might find just kind of cool in your own projects. One is Ozbox, AWS Box. It's a lightweight DIY PaaS service for Amazon Web Services. So if anybody used no.de from the Joyent days, it's kind of like that. You just put in your Amazon key, it will clone up, it'll clone a server off an AMI for you, and inside of that server will be a Git endpoint, an Nginx running, an SSL termination running. So you just run one command. In our case, the commands to deploy our app to Amazon are in the repo. We use this service so developers can actually go and push a branch, say they're testing a feature on, into the cloud, spin it up, and actually have independent MySQL databases across the network and do some real testing. We're pretty big users of Puppet. One of the recent things we've done that's worked out pretty good for us is taking most of the Puppet deployment logic, which was developed by operations, and putting it back in control of the developers so that the same Puppet modules are being used to spin up Vagrant images. So you can on your local laptop have 4 different independent VMs running, representing all the parts of this system. And you can also deploy to EC2 or Ozbox, or you can deploy to our stage environment or production. That's been a big win, like super thumbs up on getting your developers to own the Puppet logic. The only thing that the ops guys do is keep secrets, basically. Our developers do not touch these production servers. I was going to speak quickly about localization. My tip on localization is optimize for the humans that do the job of localization. Don't optimize for your code beauty. Localization is just ugly, right? It's just terrible. We do it the old school way, get text, and one of the reasons is when we do it with get text, we can fit into 30 years of tradition on how localization is done around the world. So that enables us to do things like ask the community to help us with translations, and in 2 weeks have 51 languages translated for browser ID. Because none of that community, the 288 people that did translation work on this project, none of them had to adapt their tool chains to how I think it should be done beautifully in JavaScript, right? So, pro tip there. The hard part isn't the code in this. The hard part is actually getting a whole bunch of people to understand what you're doing and write good translations for you. The last 2 to look at, Node Compute Cluster. We do crypto in Node.js. You're not supposed to do that in Node, right? You're not supposed to sit on the CPU because it blocks the event loop. So we have a cool little module called Node Compute Cluster. Really handy if you just want to distribute computation outside of your main event loop and just get in a bunch of processes. The other one, quickly, is Node Memwatch. So you guys have heard a lot of interesting things about dtrace and how we can do a lot of fancy stuff. We don't run an operating system. We run Linux in production, and we want a platform-neutral way to do some of this kind of debugging. The one thing is memory leaks are brutal in every language. I think they're extra brutal in Node. Did I mention how brutal tracking down memory leaks is in Node? It's still really hard, and Memwatch is a great little tool to go plug in to figure out where you're losing memory. Pretty much final comments for me. Polyglot is BS. Just write more Node.js. We have a metrics and logging system that has Logstash and JRuby and Elasticsearch and all this stuff, and it's a nightmare. I hate it. I want to replace it all just with simple Node programs. Unsolved problems, we've got lots. Back pressure is still an issue for us in this system. Deployment, I still think, is painful. We've done a lot of work on hitless rollouts, so we just upgrade one process at a time in the production cluster, so we never have to go down, which involves a lot of fan-dangling with load balancers and directing traffic away from nodes that are going to be upgraded. I feel like it's still not a solved problem for us, and we're hoping to do some work there in the node space. Our DB promotion rules are still pretty janky. Could use some help on that. In conclusion, I just wanted to say one kind of message. Sometimes things are hard. They're still worth doing, right? Some of these projects take a lot of people. They take a lot of time. They're not small little projects that are fun to write sometimes. Parts of this system is not fun. But the end outcome is worth it. So we're willing to do it. So my request for anybody out there in the Node and the JavaScript community is stay true to the JavaScript culture. it's cool to have critique and provide commentary to people. But at the end of the day, either you're willing to help or you're not. And if you're not willing to help, I just don't really care about your opinion. I'm sorry. And of course, I can't not put this slide up. Always bet on JavaScript. The one thing I would add was they said you can't do crypto in JavaScript. Wrong, you can. All the crypto and browser ID is being done pure client side on your phone in JavaScript, often on a modern iOS device in literally hundreds of milliseconds. And this is, for the crypto nerds, you know, full 128-bit entropy, AES-256 public key generation. You can do hard compute in JavaScript, and you should, because it's fun. Thanks a lot. Any questions before I go?